Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we're going to graph a few different rational functions that have horizontal asymptotes. So we're going to take a look at all the different types. We're going to take a look at a type where it's at y equals 0, where it's at y equals a different number, and then finally when y equals a different number and the graph actually crosses the asymptote. So we'll take a look at all of those cases. Start with problem listed as number 9, f of x equals x minus 4 over x squared plus 3x plus 2. I'm going to always start by factoring the denominator and the numerator if possible. That denominator is going to give me my vertical asymptote. So the denominator factors to be x plus 1 times x plus 2. The vertical asymptotes are at x equals negative 1 and x equals negative 2. So we're going to put the two asymptotes there at negative 1 and negative 2 for x. Okay. Now, this breaks the x axis into three intervals. To the left of negative 2, there's going to be a graph on that side. Between negative 2 and negative 1, in that little strip, there's going to be a part of the graph there, and then there's going to be a third branch out to the right of negative 1. All right, what do we do next? Well, we need to figure out what the horizontal asymptote or slant asymptote is going to look like here. Because the degree is higher in the denominator, the degree in the denominator is greater than the degree in the numerator. Y equals 0 is the horizontal asymptote. So let's add that to the graph. So marking these up, we've got x equals negative 2, x equals negative 1, and y equals 0. By the way, we will be checking to see if the function crosses the axis or not. And what we can do is by setting the function equal to the value in the horizontal asymptote. And we're going to see this time that actually it does cross. But we'll get there in a minute. Right. We need to start getting some points onto this graph. And so one thing that we can take a look at is the Y-intercept. And so the Y-intercept here is when x equals 0. Right, we want to find f of 0. And so I'm going to go back to the original function, 0 minus 4 over 0 squared plus 3 times 0 plus 2. All the 0 terms basically disappear and we're left with negative 4 over 2 or negative 2. So the y-intercept is going to be here at negative 2. And so we're starting below the horizontal asymptote. We've got to figure out, does it cross that or does it just approach it? And so here's the time to figure out if it crosses it or not. And that's by setting the function equal to 0. And if we multiply both sides by x squared plus 3x plus 2, we get this equation, x minus 4 equals 0. Right. The only way that fraction could equal 0 is if the numerator equals 0. So x minus 4 equals 0 gives us x equals 4. It's going to cross just that one time. So the rightmost interval is going to look like that. Now we've got to figure out what happens between negative 1 and negative 2. And what I do know is that the graph has to approach those two asymptotes. And so if these are the asymptotes, it could go like this in theory. It could go like this in theory. But because it doesn't cross that y-intercept the x-axis anymore, it either has to look like this or it has to look like this. And the way we can figure it out is by plugging in a value of x and see are we above or below. And so between -1 and -2, we could use -1.5. So when x equals -1.5, rather than plugging into the original, I'm going to plug back into the factored form, which was, again, x minus 4 over x plus 1 times x plus 2. And I'm basically going to look at the sign. What happens when I substitute in -1.5? Well, -1.5 minus 4 is definitely going to be negative. -1.5 plus 1 is -0.5, so that's negative. And -1.5 plus 2 is a positive number. So I've got a negative number over the product of a negative and a positive number, or negative over negative. When we divide a negative by a negative, we get something positive. So I don't know exactly where this graph is, but I do know that it's going to be U-shaped in that interval. Now, if I plugged in -1.5 and actually did the calculation, I would have had -5.5 over -0.25, which is about positive 22. So it actually would be a lot higher than where I have it. But for a quick sketch, this isn't bad. When we want to get it a little more precise, though, we would plug that in. And I'm just using this here again. -1.5 minus 4 over -0.5 times positive 0.5. This is -5.5 over -0.25. And again, if we divide this out, we're going to get 22. So even though I drew it here, it's actually going to be somewhere way up here, even farther up than that. All right, time for the last piece. To the left of -2, and I'm going to use the same kind of approach. It's either going to have this kind of behavior, or it's going to have this kind of behavior. And by figuring out a point above or below, I can track that down. And so I'm going to just use something to the left of -2, like -3. And I'm using the same sign chart approach. -3 minus 4, that's negative. -3 plus 1, that's negative. And -3 plus 2, that's negative. So I've got a negative numerator, a positive denominator, right? Two negatives multiplied to be positive. So this is going to be negative, and we're going to be working below. I can work this out. -7 over -2 times -1 is -7 over 2, or -3.5. So when x is -3, -3.5 is on the graph, and it's going to look something like that. All right, that's the first one. Horizontal asymptote at y equals 0, and it did cross the asymptote. The next one, the numerator and denominator are linear. Start with the vertical asymptote. That is where x plus 5 equals 0, or x equals -5. For the horizontal asymptote, notice that these, the numerator and denominator, have the same degree. So the horizontal asymptote is y equals 3 divided by 1, which is 3. Now we need to figure out where this is going to be graphed. So a couple of points that we can find are the intercepts. The x-intercept, which is where y equals 0, we can get by setting the function 3x minus 6 over x plus 5 equal to 0. That can only be true when 3x minus 6 equals 0, or when x equals 2. So I've got a point here. That tells me that I'm probably working in that bottom right quadrant, but I don't know if it crosses the asymptote or not yet, so I'm not going to sketch anything yet. Now I need to find the y-intercept, which is where x equals 0. So f of 0 equals 3 times 0 minus 6 over 0 plus 5, or negative 6/5, and that's negative 1.2. So when x is 0, negative 1.2. Finally, I need to see if it crosses that horizontal asymptote anywhere. And so we're going to set the function 3x minus 6 over x plus 5 equal to 3. Multiply both sides by x plus 5. And we get 3x minus 6 equals 3x plus 15. When we subtract 3x from both sides, we get negative 6 equals 15, and that can't happen. So it's not going to cross this. We can add more points to make it more precise, but I know it's going to have that kind of shape. On the left-hand side, I need to figure out, is it up here or is it down here? And so I can just plug in a point to figure that out. Something to the left of negative 5. So maybe we try x equals negative 6. 3 times negative 6 minus 6 over negative 6 plus 5. On the top, that's negative 18 minus 6, or negative 24. On the bottom, negative 6 plus 5, that's negative 1. And negative 24 divided by negative 1 is 24. So at x equals negative 6, it's going to be way up off the graph, but I can tell that it's going to have that kind of shape. The domain would be everything but negative 5. The range would be everything but positive 3. And this is increasing everywhere. All right, let's try one more. I'm going to factor both the numerator and denominator because it's going to make it easier for me. The numerator, if I take out a 2 first, I get x squared plus 5x minus 6, and that factors. So this numerator is 2 times x plus 6 times x minus 1. The denominator is x plus 3 times x plus 4. And I can get a lot of things out of here. First, I get the vertical asymptotes. The vertical asymptotes come from the denominator. That's x equals negative 3 and x equals negative 4. Second, I get the zeros, or the x-intercepts. Those come from the numerator, x equals negative 6 or x equals positive 1. So I can get those that information onto the graph right away. X equals 6, x equals negative 1. The asymptotes were at negative 4 and at negative 3. So again, we've got that little strip. We're going to have to figure out what happens in there. And from the last one, we get an idea that it's going to be going up or down real quickly. We do need the horizontal asymptote. Notice that the degrees are the same. So the horizontal asymptote we get by dividing the leading coefficient in the numerator, 2, by the leading coefficient in the denominator, 1. That's y equals 2. Like so. And that right side looks a little funny, right? We've got 2 points at the same height. And so that suggests that the graph has to turn around somewhere. But it's also supposed to be approaching... Oh, that's my problem. I've got my intercepts. I said negative 6 and positive 1, but I put them at positive 6 and negative 1. So through the magic of the eraser... Right? I just felt that something didn't look right there. So x equals 1 and x equals -6. That's a little better. And I already know, well, I have a pretty good idea that on, well, let me just check to see where it crosses. I have to set the function equal to the value from the horizontal asymptote. So back to the original function, 2x squared plus 10x minus 12 over x squared plus 7x plus 12 equals 2. Multiply both sides by the denominator. Gets us 2x squared plus 10x minus 12 remaining on the left. And distributing on the right, we get 2x squared plus 14x plus 24. Now I can subtract 2x squared from both sides, but I do have an equation that I can solve here. If I subtract 10x from both sides first, I end up with -12 equals 4x plus 24. Subtract over the 24, I have -36 equals 4x. And finally, that gives me -9 equals x. So that tells me that the graph crosses the horizontal asymptote at x equals -9. So right here. On that left branch, what I know is true, has to happen is it's going to come closer to this intercept, this asymptote, and it's going to go up, and then it's going to come back down towards the asymptote at some point. So up and back down. On the right-hand side, the only thing that I don't have is the Y-intercept. The Y-intercept is where we put in 0 for x. And so we would have 2 times 0 squared plus 10 times 0 minus 12, which is just going to be -12. And on the bottom, we're going to have 0 squared plus 7 times 0 plus 12, which is just going to be 12. And so this equals -1. Use the asymptote behavior to figure out what that one looks like. Now for the last one, I've got to figure out, okay, is it going to be between those two asymptotes going down or going up? And again, I just need to pick a value to try this with. Between -3 and -4, I'm going to use -3.5. And again, I'm looking inside that middle branch to figure this out. So I'm going to plug into this factor form. It's a little easier to do the arithmetic for me. It's going to be 2 times -3.5 plus 6 is 2.5. And -3.5 minus 1 is -4.5. In the denominator, -3.5 plus 3 is -0.5. And plus 4 is +0.5. So if we multiply these out, the numerator becomes -22.5, the denominator is -0.25, and negative divided by negative is positive. And this is going to be a really big number. It's going to be, if you divide it, I believe that works out to be 90. So it's going to be somewhere way up, but it's going to be between those two. All right, we ran through a few different cases. We had a horizontal asymptote at 0 where the graph did cross it. We had a horizontal asymptote where it didn't cross other than 0. And then finally we've got one here where the horizontal asymptote was at a height of 2 and the graph did cross it once. All right, that's it for these rational functions. I'll see you in the next video where we'll graph a different scenario.